Hello and welcome to FIT2102 Programming Paradigms. My name is Tim. I'm the Chief Examiner for this unit. If you are interested, here is my homepage at ialab.it.monash.edu, /Dwyer. I guess what's relevant to this unit is that in a past life I was a software engineer with Microsoft. And for a long time, I've been very interested in building complex interactive visual systems for exploring different types of data. And in my time at Microsoft and since, I have encountered many different solutions to complexity in these kind of interactive asynchronous systems. And I've found that they're incredibly important in modern software. And so a lot of the themes explored in this unit are around dealing with that kind of complexity and abstracting away complexity into pieces that you can reason about and work with sensibly and create robust and reliable software. Okay, so in this unit, we are going to explore several different programming languages. There is a real focus on functional programming languages, which are becoming more and more important. Not only specific functional languages, but the functional programming paradigm is becoming very important and is supported by more and more mainstream languages. So we will be transitioning your way of thinking a little bit away from imperative styles of programming and object-oriented ways of structuring data, which is probably what you've learned until now, to more functional approaches and also declarative approaches to modeling problems. And we'll talk about the different advantages to doing that. There are many. The big thing, I guess, and the theme underlying all of this is trying to abstract away complexity. We'll also be looking at some theory that underlies these programming paradigms, in particular lambda calculus, and this is a tool that helps us to think again abstractly about programming. So here's the schedule for this unit. We will start off with JavaScript as an introduction to functions and functional programming. We will see that JavaScript, although it's not primarily a functional language, has support for quite rich functional programming concepts, as well as support for the kind of object-oriented programming that you're probably familiar with. Then in about week 3, we will transition to TypeScript as an introduction to compiled languages that help to make sure that your program is correct by checking types. In week 4, we will look at some container structures that you can model using functions and functional reactive programming in particular, which is a method for handling asynchronous behaviors. And we will use functional reactive programming, in particular the observable data structure, to complete assignment 1, which will be to create a fun computer game. In week 5, we will get into the theory a bit more, starting to look at lambda calculus, and this will transition us into Haskell, which is a real, pure, lazily evaluated functional language. We'll spend most of the rest of the course exploring higher order functional programming concepts using Haskell, with the exception of week 12, where we will look at a more declarative programming paradigm. At this point, I'd like to draw your attention to the course notes that go along with this unit. They're available here at tgdwyer.github.io. They're linked from the Moodle, of course, and each week there will be prescribed readings, a couple of sections prescribed for you to read before you come to class. It's very important that you do so. When class starts, you'll be expected to get up and running very quickly, so it's super important that you do read these before class. The source for these course notes is all on GitHub. If you spot mistakes or anything, I've been working on these for a few years now, but there will always be mistakes, and of course improvements are possible. If you want to suggest something, feel free to have a look at the Markdown source directly, and you can even go so far as to edit these things in place. Just press the little button here, and when you save your edit, it will send me a pull request to incorporate your changes. So, I do welcome your contributions if you'd like to make any. The most important thing that we study in this unit is the underlying programming language paradigms, that is the concepts that concern the language's design and use. And they're agnostic to the particular choice of language. But we do have to choose languages that we try these ideas out in. In this course, we have chosen JavaScript, TypeScript, and for the most part, Haskell. There are reasons for this choice. Firstly, they are languages that have features that are necessary to support the programming paradigms that we are going to encounter. They're also immensely popular languages, especially JavaScript is now the language of the web. And in relation to functional programming, JavaScript is important because these functional programming concepts are becoming very widely used, as we will see shortly. So there are good reasons why we choose these. There are many other languages where you could explore functional programming, and I encourage you to do so if you have a preferred language in your own time, to go and see how higher order functions can be used. But once again, the important thing is the semantics of the language, that is the meaning behind the programs that we write, not the particular syntax. So what do we mean by that? Well, here's a snippet of Python code and a snippet of JavaScript code. These two programs are both doing the same thing, really. Semantically the same thing. They're both summing over a range of numbers from 0 to n, up to but not including n. The way they do it is a little bit different. They're both using these imperative for loops, but while Python has a built-in range function which returns some iterable structure that returns these numbers, in JavaScript we have to implement the for loop slightly differently. But if we zoom out and think about what these programs are actually doing, think of them as black boxes, then they are, for all intents and purposes, identical. So the syntax is different slightly, but the semantics is very, very similar. There is in this unit an emphasis on the practical, that is actually teaching you features of programming languages that you can use in practice to solve problems. So we try to go into enough depth in the various languages that we explore that you can use them in practice. And we try to empower you to become a programmer in your own right. So we don't just show you toy snippets of code. We allow you to get your hands dirty creating solutions to problems yourself. We give you real tools to use. That is, you're not just using toy sandbox environments inside of web browsers, but you're actually using the real programming tools, using your own editing environment. We try to help you to set all that up. There are, of course, limitations to what we can cover in a one-semester second-year unit. So while we try to go deep enough that you'll come away with some important concepts, this is not a complete programming languages course. Often those kinds of courses come at higher year levels, third year, and they will often go so far as to teach you how to create a compiler for your own language or to design a new language. We're not going to go that far, although we will talk about how things like compilers work to some degree. And we will reflect on programming language design, but not to the degree where you could go off and create your own language. As I said, this is a flipped classroom unit, which means that it's very important that you do the work before you come to, that you do the reading at least before you come to class, and that you do your tutorial homework before you attend the workshops. So the assessment for this unit is 2 assignments, each worth 30%, which will be completed individually. Very important that you don't plagiarize other people's work and that you work alone on these assignments. The other important assessment task is your tutorial homework. So each week in the tutorials, you'll be given a worksheet. Now, the tutorials you'll be working with other people on. So you will form into groups and support and work with each other to complete that tutorial homework. Each week's homework is worth about 4% of the total unit mark for a combined 40% of the unit. So classroom activities for this unit are structured into tutorials and workshops. The tutorials are smaller classes led by a couple of tutors who will assist you to do your work in teams and also to apply the assessment from the previous week's work. Workshops are classes with me that happen later in the week. So for most of you, you should be enrolled in a tutorial class before your workshop class. In the workshops, we will again use the flipped classroom model, so it's expected that you've watched these recorded lectures before you come to class and that you've done the reading as well. And also hopefully by then you will have done a large chunk of your tutorial work. So the workshops are also intended to be practical in the sense that we'll be solving problems in class, trying out our programming techniques in class. For this workshop, at the end of it, you should have come away with an understanding of the difference between syntax and semantics, as we've already discussed. We will also be talking about, again, abstraction from machine level programs to programs implemented in higher level languages, and also some models of computation that are relevant to the design of programming languages. Another important thing that we will look at this week is transitioning away from the kind of imperative loops that you've used many times, so for loops and while loops, into using recursion, which is an idiomatic form of loop in functional programming. We'll see how the stack is important for recursion, and that it can potentially cause issues. And once again, we'll be trying out these concepts in JavaScript. And so by the end, we will actually be creating JavaScript programs. So I keep talking about levels of abstraction in programming languages. What do I mean by that? Well, it's important to reflect upon the history of programming and where we've come from. For your interest, if you like, you can watch a little documentary that I've linked in the Moodle page for this week about the Apollo program software development. Back in those days, in the 60s, they had very rudimentary programming languages, and in fact, the languages that they had were very, very close to the machine level. There wasn't very much abstraction at all from the operation of the computer itself, the machine, and the way that programmers had to think to solve problems using that computer. By contrast, modern computer languages are quite far removed from the operation of the machine, although there are elements of the machine's operation that have made their way into very modern languages. And that's what we talk about when we talk about the imperative programming paradigm. The fact that fundamentally, many so-called imperative programming languages simply provide a list of operations that the computer completes in order to implement an algorithm or solve a problem. Now, that's fine, and in your early encounters with imperative programming languages, you do begin to think this way. You do begin to think of solving problems by setting out a list of instructions that the computer has to perform. However, it's not always the best way to model the real world. And some programming languages offer alternative ways to model real-world problems. So here, very roughly, is what's going on inside your computer when it runs a program. It has a CPU which receives instructions loaded from memory and stores data in memory. Perhaps it interacts with I/O devices. It doesn't really matter too much. You should have studied some computer architecture in your first year units. We're not going to get into that in detail at all this semester. In fact, we are deliberately trying to get away from this. What I want to draw your attention to, though, is that the way that modern computers work is very close, their architecture is very close to a model for computation proposed long ago in the 1930s by John von Neumann, who was a computer scientist who came up with an abstract model for how computers might work. And at the time it was rather theoretical. It was really at the dawn of the computing age. And it had a lot in common with another model for computation which truly was theoretical, the Turing machine model by Alan Turing. And that model of computation was again an abstraction, but one very close to this imperative paradigm, where there was a tape running through the machine that carried instructions, and the machine would read instructions from the tape and do various things, and perhaps write to the tape as well. While that was sufficient for Alan Turing to reason about computation and prove various things about computation that were very important, it's not necessarily a great way to think about programming and solving problems in programming languages. And so we'll be learning about another model for computation called the lambda calculus, which is the inspiration for functional programming languages. And as we'll see, it's quite useful in terms of allowing us to compose elements of programs and manipulate programs in an abstract but very useful way. Now, let's get down to actual programming and talk about JavaScript. So JavaScript, as I said, it's the language of the web, and it's probably the most widely used language for implementing interactive programs, and also for handling asynchronous behavior. When you think about what a modern web platform involves, there's a lot of asynchronous communication between client and server, or many communication between many different services. And so this can be the source of many difficult programming problems: how you schedule these communications and how you handle unpredictable asynchronous events occurring. And so the solution to these problems that is starting to appear more and more is elements of functional programming, and you'll see sophisticated functional programming ideas being used in many different JavaScript libraries, such as jQuery, React, D3 is a visualization library, rx.js, which is one that we're going to look at when we talk about functional programming, Mocha, which is the library used for the tests in our worksheets, but many more as well. And so functional programming concepts are very important. They make these libraries flexible and usable in lots of different ways, and also robust. So I think at this stage, rather than trying to just talk endlessly lecture style about various features of the JavaScript programming language, I think it's probably time to draw your attention back to the readings for this week, particularly the chapter on the introduction to JavaScript. So again, the course notes are tgdwyer.github.io and linked from Moodle as well. And the two readings are levels of abstraction. The second one is this introduction to JavaScript. And this is going to go through various features of JavaScript, sufficient to support the programming paradigms, the functional programming concepts that we're going to talk about a little bit later. And it goes through each in turn. I think rather than me trying to talk about it, it's best if we get you started so that you can play with it and experiment with these concepts as quickly as possible yourself. If you have a web browser, all web browsers have this, but particularly Chrome is the one that we encourage you to use. So Chrome has a set of developer tools which you can open up from this so-called hamburger menu. You go down to More Tools and then Developer Tools. It says here that on Windows the keyboard shortcut is Control-Shift-I. The one I use is F12, and I believe that works on Linux as well. I'm not sure what it is on Mac. I'll leave you to find out yourself by navigating through this menu, but I'm sure there is one. Okay, so when you hit, in my case, F12 to open up the developer tools, this is what you will see. I've made that very large. You'll see this console open up. Console is the second tab. If it's not on it automatically when you start, then tab across to the second one. So on the console, you get a command line and a prompt to start typing things. What we have here is a so-called REPL for JavaScript. That is a read, evaluate, print loop. So we can enter JavaScript directly. So for example, we could take this line of code from our course notes and paste it into the REPL and hit enter. And there we are. Now we've defined a variable called z, whose value is going to be 1. By the way, we've said that it's const, so that that defines it as immutable, not changeable. And if we were to try and change the value of z now, we would see that it causes an error. So declaring it const or constant means that it can't change. If we want to create a variable that can change value, then we would use the let keyword. So let w equals 1, and now we will be able to change this variable like so. We can see at the moment we're defining these variables in the so-called global scope. That is, whatever functions we create now, we'll be able to see and reference. And if we declared the variable with a let, then they could also potentially change the value of these variables. So these variables are at the global scope. In JavaScript, we define scopes, which are restricted areas of visibility inside curly braces, like so. So we can say let x equal 1 and do something with that, console.log x, and right, so we have printed out to the console the value of this variable x, which was 1. But seeing as we put that block of code inside these curly braces, the open curly and the closed curly, this x is no longer in scope. In fact, it's probably been garbage collected and gone. So if I were to try and inspect the value, it says that at this level, x is no longer defined. So that's how you declare scopes. Scopes are usually declared inside of other programming constructs, such as functions is a very important one. Is that indeed the next thing? Down here, we talk about functions. I've just skimmed over a bunch of things that you should pay a bit more attention to in JavaScript, especially if you're coming to JavaScript for the first time. You will find that there are operators that we will be using in the tutorial activities, in particular this modulo one. What's modulo? Modulo is the remainder after dividing, so 9 modulo 2 is 1. So 9 divided by 2 is 4, remainder 1. And there are equality operators, so hello equals hello is true. Note that there are two types of equality checking operators in JavaScript: a double equals and a triple equals. Actually, the triple equals is the one you want to use most of the time. The double equals has slightly looser rules of evaluation that may involve type conversions. So I strongly encourage you to use triple equals and similarly not equals equals to check for inequality. Okay, apart from that, there are logical operations and or. You will be familiar with their equivalent operations in Python. If you're coming from C or C++ or Java, the logical operators are the same. In fact, the syntax in JavaScript is heavily inspired by Java, as is the name of the language. But there are significant differences, which we will talk about later. You'll also see me using these so-called unary operators, incrementing values of variables, decrementing, and so on. There's another one that you'll see me using, which is quite a terse way of doing an if-then-else. So we call it a ternary conditional operator. Basically, you have a condition and then a question mark, and the result of the expression if that condition is true, and the result if it's false. For example, what can we do? Do we still have a variable in scope? What's z? Okay, z is a variable that's in scope. If its value is 1, then we are going to console.log yes, else console.log no. Yes, z equals 1. All right. It's important to note that this is an expression, not just a statement. So in fact, we could have returned, instead of executing a console.log, we could have just returned a value here. And you can see immediately that the interpreter is telling me that the result of this expression is indeed yes. So this expression here returns a value, which we could even assign to a variable, const the result equals, and the result is yes. All right, so this is one of the very handy things about JavaScript, is that if you have a browser, you can immediately start fiddling with the language features, and you can do that even as you are reading the course notes. You can start trying these things out. And that's not quite how we're going to do the activities in the tutorials though. For the tutorials, you will download the code bundle from the Moodle page, which is here. And we will be at week 1. So you will go to the tutorials and you'll be able to get this week 1 tutorial code. And when you download it, you'll get a zip file which you can extract somewhere on your hard drive. I will put it nowhere in particular. Okay, and now going into the code bundle in this week 1, you will find that there is a main.js file which you can open up in an editor to start completing the tasks. The worksheet checklist is an HTML file which you can open up in your browser like so. And you'll see If you click on these sections here, you will get the instructions for what's required to be done. And below the instructions, you will see the results of a bunch of tests that are being run on the main.js file, which we saw in that directory and which we can open up in a code editor. Use any editor you like. I like to use VS Code. So if you have installed VS Code, then you'll be able to open it up. You'll be able to open a folder, go into our week 1 code bundle. There it is. And you can open the whole folder. And you'll see that we have these files. Here is where you're going to do your work. So at the top, you will need to add the names of your group members into this table. If all goes well, then I expect that usually the contributions will be even across all the people in the group, in which case the marks will be allocated fully to everybody in the group. If there's a problem though, you may want to vary from that formula. I'll leave you to work that out. Speak with your tutors if you're particularly concerned, and if they're unable to help you, then you can speak to me. The idea of these team activities, though, is that they're meant to be fun. You're meant to form into groups and support each other to learn. If you are the kind of person that feels you have absolutely no trouble at all and you just want to get it done as quickly as possible, well, that's good for you, but you will actually benefit from working with other people. In the real world, we have to work with other people. And actually, you'll learn a lot. You'll find out when it comes time to try and explain things to your group that perhaps there are gaps in your understanding. And vocalizing, explaining out loud how your code works, for example, will really support your understanding. And in some cases, maybe you'll realize you don't understand it as well as you thought. So I think that's a really useful activity and a good use of your time, and working in teams is also a good way to balance the workload so that nobody gets too stuck for too long on one thing. You can share the workload, that's fine. When you're assessed the following week in groups, you will be required to answer questions about the code that you've written, and anybody on the team may be asked any questions, so it's important that everybody understands everything. Even if you weren't the person who particularly solved the problem, it's important before you submit your file. This main.js file is the one that you'll submit in Moodle. Before you submit, and certainly before you come to class, that you have taken the time to go back and understand what these exercises are, what the solutions are, and how they work. All right, so this is the place where you will do your work, and so the first few exercises are very simple. Let's see, the first exercise is let and const keywords. So create a mutable variable called a variable and assign its value to 1. Look, for this very first one, I'm just going to give you the answer. So a mutable variable, we declare with which keyword? We talked about 2, const and let. Well, it's not a constant, it's mutable, it's changeable. And so we're going to use the let keyword. And we're going to define a variable, and we're going to set its value to 1. And when we save this file and then open our mocker tests and reload them, we'll see that first pair of tests goes green. So that means we've entered the right solution. I'm not going to go through all these exercises, that's your job. But hopefully I've got you off to a good start. That's the process, that you enter code into this main.js file and reload the HTML file to see the tests run. You can open the worksheet and the code next to each other, like so, and that's really quite a direct, almost live coding way to work. Okay, so I will leave that there, and hopefully that's enough to get you started. Do read, once again, the course notes for JavaScript before you come to class. And then I think if you've done that, you will find the first week's worksheet very easy. Okay, so that's all I wanted to say before class. I will see you in the workshops. Good luck with the tutorial, and I hope you have fun with this course. And we'll be seeing a lot of each other. Have a lot of fun, and see you soon. Bye now.